Hello! Today we are going to do 7.4, vertex form of a quadratic function. So to start things off, let's just introduce what vertex form of a quadratic function is. And that's really just when a quadratic function is written in the form below. When a quadratic function is written in the form below. This is called vertex form. So we have y is equal to a times x minus h squared plus k. Okay, and a, h, and k are all real numbers. Maybe we could write that inside. A, h, and k are elements of the real, and a cannot equal to 0. Because if a equals to 0, if a is 0, then this whole thing gives me 0, and that doesn't give us a quadratic function anymore. It gives us a constant on the right-hand side, which will give us a horizontal line. So, a couple of restrictions there, but that is a-okay. All right, a couple of interesting things that we could get from vertex form of a quadratic function. The first one being that a value gives us the same information as it did in factored form. So the a value denotes the direction of opening. So before we had said that if a is greater than 0, that means a is a positive value. If the a is positive, that means that the parabola opens up. And if it opens up, that means that it has a minimum. Right, and that minimum occurs right down there. And in the opposite way, if a is negative or less than 0, that means a is negative. That means the parabola opens down. And if our parabola opens down, that means that it has a maximum. And the maximum occurs right at that peak there, at that vertex. Okay, so this is exactly identical as to what we had before. And keeping in mind, this is greater than 0, less than 0, because a is not able to equal 0 itself. All right. Our vertex is actually really easy to find in vertex form, and that is just taking the value h, comma, k. And that's it. That's all. We could pull it directly from the equation, which makes life so easy. And same with the axis of symmetry, because the axis of symmetry is x is equal to the x coordinate of that vertex. That means x is just straight up equal to h. You should be kind of cautious, though, because notice in the formula, we have negative h over here, whereas in our vertex or an axis of symmetry, we have a positive h. So the h that we will be using in our vertex and our axis of symmetry, that means that we should have the opposite sign. So let's write that down here. Maybe we'll write it down in a different color. So the h in the equation is negative. It's a minus, meaning the h in the vertex and the axis of symmetry will have the opposite sign. Okay, so that's just something to be cautious of. Really easy to make that mistake, so just be careful. All right. And all we're going to do is we're going to go through two different functions in vertex form. We are going to extract some information. We're going to graph it. We'll double check we're right on Desmos. And then that's it. And that's all that we're going to do in vertex form. So here we are starting off with this function y is equal to x minus 4 squared minus 1. What is the direction of opening? Well, here we have our a value is 1, right? When we don't have an a value written down, remember it's not 0, because if it was 0, first of all, that's not allowed to happen, but it would make the whole first chunk of that equation 0, so all we would have is y is equal to negative 1, and that would be a horizontal line, not a parabola. But anywho, 1 itself is greater than 0, which means it is opening upward. Whoop, whoop, whoop. Next, if it is opening upward here, that means we have a minimum. All right. So with vertex form, we could find the vertex and the axis of symmetry really, really easily. But the thing or the disadvantage about vertex form is that it's hard to or a little bit harder to find the intercepts. So all we know, or all we should know or remember from before, is that our x-intercepts occur when y equals to 0. We're going to have to do a little bit of work. So I'm going to do the work down here. Okay, but we can do it nonetheless. So in our equation here, let me just airplane mode this. So in our equation, we have y is equal to x minus 4 squared minus 1, right? But if we are looking for our x-intercepts, that's when y is equal to 0. So instead of y, we can plug in 0, and we can solve for x. Okay. The first thing we're doing when solving for x is try to get it all alone. So we're going to add 1 to both sides to get rid of this negative 1 here. So we get 1 is equal to x minus 4 squared. We are trying to get rid of that squared on either side, so we're going to square root both sides here. When we square root the right-hand side, we'll just be left with x plus 4. But when we square root the left-hand side, the square root of 1 is in fact 1, but it is also negative 1. Okay, this is a very key thing, because 1 times 1 is positive 1, but negative 1 times negative 1 is also positive 1. We have to account for both of those values. So this is something that is very key that we'll need to make sure we keep an eye out for, and we do every single time. Once we have this, we split up our equation into two possibilities. So we could have positive 1 equals x minus 4, or we could have negative 1 equal to x minus 4. Okay? Because both of those are valid possibilities here. From this point on, it's quite simple to solve for x. We add 4 to both sides to isolate for x. And on this first equation, we get 5 is equal to x. And on the second one, we get 3 is equal to x. And that's all well and dandy. But remember that this step here is a really key step. We need to remember that positive 1 and negative 1 are both the square root of 1. So we have to accommodate or account for both. So here we have x is 5 and x is 3. And we can write it as coordinate points as well if we wish. Both are acceptable. All right. Our axis of symmetry. Remember, our axis of symmetry can be pulled straight from our vertex form of our equation. So we have x is equal to h. Remember that our h here is going to be the opposite sign as what's given. So we'll have x is equal to positive 4 rather than x is equal to negative 4. And this makes sense if you think about it, because we know our axis of symmetry occurs smack dab in between our two x-intercepts. Because of our x-intercepts being at 3 and 5, smack dab between the two of those is 4, so it should make sense to us. Our vertex again, we could pull this straight from vertex form. We'll have the coordinates 4, comma 1 because we have h, comma k. So that's 4, comma negative 1. And that's super simple to pull from our equation. Remember, the h is the opposite side, but the k is exactly as read in the equation. So we have 4, comma negative 1. For our y-intercept, this is something that we also can't find just by looking at the equation, kind of like our x-intercept, but we know that this occurs when x is equal to 0. So we can plug in 0 every time we see an x into our equation and solve. So we have y is equal to x minus 4 squared minus 1. But instead of writing x, we can put 0. And then go ahead and solve that way. So we have y is equal to negative 4 squared minus 1. So y is equal to 16 minus 1. So y is 15. All right. At this point, we have lots of points that we can go ahead and start graphing. We have our vertex, we have our x-intercepts, and we have our y-intercept. And then we could use the axis of symmetry to find any additional points in case that happens to be useful. And we'll go ahead, start graphing that, and then we will look at Desmos to ensure that we are on the right track here. So we'll start off with our vertex. So our vertex was at 4, negative 1, so that's going to give us the point right here. Our x-intercepts occur at 3 and 5, so here's 3, here's 5. And our y-intercept occurs at 15, so 2, 4, 6, 8, 10, 12, 14, 15. Okay. And just again, this imaginary line that I'm drawing in pink here is our axis of symmetry. It's that vertical line that passes through our vertex. This is useful because I can see that if I have a point that is 4 to the left of my axis of symmetry, I will also have a point that is 4 to the right of my axis of symmetry, because that is what makes it symmetric. Okay. I could go ahead and start connecting those dots with a nice smooth curve, and then draw arrows at the end of it all. And I noticed that my graph, oh, that didn't quite make it. My graph is in fact opening upwards, just as I predicted from my a value there. And if we plug it into Desmos on the side, we go y is equal to x minus 4, close bracket squared, minus 1. I end up with those same key points. Right, and if I plug in x is equal to 8, which is where I added that new point, I also see 8, 15, which we figured out together. Awesome. From here, we can figure out our domain and our range. Our domain is our furthest to the left to our furthest to the right, so we have negative infinity to positive infinity. And in set notation, we have the set of all x, such that x is an element of the reals. And our range, we have a minimum. So our minimum y value is actually going to be where our vertex is, which is our negative 1. And it continues on to positive infinity. Or we have the set of all y such that y is greater than or equal to negative 1. And y is an element of the reals. Negative 1, make that a little nicer. Perfect. And that's it. That's all. So that is how we would go ahead and figure out all the characteristic information from our quadratic function in vertex form. We have one more example to do together. What I'd like you to do is to pause the video right away. Try this on your own. Try finding my intercepts, my max, my min, my vertex, my axis of symmetry, domain and range, all that beautiful stuff. And then once you think you've got it, come on back. Make sure that you've got all the correct answers, and then we can work through it together. All right? Perfect. All right, pause the video. Give it a go. All right, welcome back. So here we have our next equation. We have y is equal to negative 2 times x plus 3 squared plus 8. So direction of opening, we know we're looking at our a value, and our a value here is negative 2. Because negative 2 is in fact less than 0, it is negative, we are opening downward. And if we are opening downward, that means we have a maximum. So we are opening down, and there is some sort of maximum value. Our x-intercepts. Remember, our x-intercepts occur when y is equal to 0. Our x-intercepts we can't easily find using our vertex form equation, but we can still plug in y is equal to 0 into our equation and solve that way. So we have 0, rather than y, is equal to negative 2 x plus 3 squared plus 8. And we can go ahead and isolate for x. First thing we're going to do, so it's reverse order of operations, so we're doing addition subtraction first. So we're subtracting 8 from both sides. So we get negative 8 is equal to negative 2 x plus 3 squared. Next, we are getting rid of our multiplication division. So we're going to divide both sides by negative 2 to get rid of that multiplication there. So we get 4 is equal to x plus 3 squared. The next thing we're going to do is get rid of any exponents. So we are square rooting both sides. When we square root the right-hand side, we just end up with x plus 3. But when we square root the left-hand side, we end up with positive 2 as well as negative 2, because 2 squared is 4 and negative 2 squared is 4, which means we have to split it up into two possibilities, which means we could have positive 2 is equal to x plus 3 and negative 2 is equal to x plus 3. From there, we can solve each of the equations by subtracting 3 from both sides. And for the first one, we get negative 1 is equal to x, and the second one, we get negative 5 is equal to x. So we have x is equal to negative 1, x is equal to negative 5. Or we could write those as coordinate points. Again, whichever we prefer would be all right. Next, our axis of symmetry. Our axis of symmetry we could pull straight from our equation. It gives us x is equal to h. Our h value is the opposite sign as what's showing in our equation, so we will get x is equal to negative 3. Which again makes sense if you think about it. Our axis of symmetry should occur smack dab between our two x-intercepts. For x-intercepts occur at negative 1 and negative 5. Right between them should be negative 3. So we know we are on the right track. Our vertex occurs at h, k. So it'll have the same coordinate point as our axis of symmetry. So negative 3, 8. Next, our y-intercept. We know our y-intercept occurs when x is equal to 0. So we're going to plug in 0 every single time we see that x in our equation. So we get y is equal to negative 2, 0 rather than x, plus 3, plus 3 squared, plus 8. Okay, so we are going to get y is equal to negative 2 times 3 squared plus 8. And 3 squared is 9. 9 times negative 2 is negative 18. And negative 18 plus 8 is going to give us negative 10. So we are going to have a y-intercept at y is equal to negative 10. Alrighty. We've got enough points that we can start graphing this. So we've got the vertex, our x-intercept, our y-intercept, as well as our axis of symmetry that'll help us find any additional points. We also know that our graph should be opening downwards. So that is a good check that if it's not opening downwards, then we can take a look to see if we maybe made a mistake somewhere. So first point that I like to plot is I like to plot my vertex. So I go -3 and then +8. So we're going to have a point there, right? 2, 4, 6, 8. 1, 2, 3. Beautiful. Then we're going to have x-intercepts at -1 and -5. -1, 2, 3, 4, 5. And we're going to have a y-intercept at -10. 2, 4, 6, 8, -10. And again, knowing that my axis of symmetry is an imaginary vertical line that goes through my vertex, if I have a point that is 3 to the right of my axis of symmetry, I know that I will also have a point that is 3 to the left of my axis of symmetry, because we know parabolas are symmetric. With this, we can go ahead and connect our dots with a smooth curve. And then once we are done, we can go and, oops, it's a little bit wonky on the end there. And double check with Desmos to make sure we are on track here to be making, or to get the same parabola. So we have y is equal to -2 x plus 3 squared plus 8. And there we go. We can see that we have got the same points, and we have that same intercept. And we can double check that we had the same intercept because we plotted the point x is equal to -6. Or sorry, we could double check that we have the same point that we've added in, and we do get -6, -10, which is exactly what we plotted. All right, finishing things off here, our domain goes from -infinity to +infinity, or the set of all x such that x is an element of the reals. And our range goes from -infinity to our maximum, which occurs at 8. And 8 is included, so we use the hard bracket, and we use the set of all y such that y is less than or equal to 8, and y is an element of the reals. All right, that is it. That is all for our 7.4. You have 2 questions to do for homework, and we'll catch you again for 7.5. Adios, muchachos.